We are ready to start the real lecture. Today's real lecture, let's call it like this. So, what we listen from Ilaria is indeed an application of two deterministic models. We talked about uncertainty, but we didn't give the predictions in terms of probability distribution. So it is these are two deterministic models. And deterministic models, let me look for, I hope there is some try out, okay, thank you. Yeah, it's here. The deterministic model, basically, as we said at the beginning of this lecture, is a box which contains some equations, and then we get an input, okay? And then we get an output, which is our actions. And then we may have a change, a climate change, and we have also climate change. And then I said, this box contains some equations. The difference between ModFlow and the machine learning is that the equations in ModFlow are physically based, as we said, equations. And in machine learning, the equations are just regression relationships, okay, with different shapes, depending on if it is a forest or if it is LSTM, which we started introducing, and then today we give some more details. And now, let me just share the screen because I don't want, otherwise we don't see anything. Okay, we don't see the graph. So basically, then what makes the difference is the nature, the structure of the equations that are inside this box. And indeed, it is a big difference because on the one hand, we have physically based equation, on the other hand, we have just regression relationship, which don't care apparently about physics. On the other hand, Ilaria pointed out very well that there is anyway uncertainty, which means that these physically based equations in ModFlow are not perfect. They don't give a perfect representation. They give a representation which is, even if it is physically based, is to some extent unreliable.
Assumptions?
Yeah, maybe assumptions, maybe the input data that are not correct. Maybe assumptions, yes. Some people say that the problem basically is in the assumptions. And some people say maybe the input data, maybe the calibration. The calibration is, there are parameters to be calibrated as we learned. So there are some limitations, some uncertainty that comes into play. And therefore, this is why some people say, yeah, there is some conceptual basis, but if the concept is to some extent wrong, why should I care about the conceptual basis? And therefore, they say, let's adopt a regression relationship, which is, even if it's not physically based, may be more reliable, because at the end of the story, we care about uncertainty. So if the prediction is more reliable, from an engineer, from the point of view of an engineer, one may say, why not? But the problem is that this comparison depends on the case study, on the quality of your data, on many things. And there is also the problem that, how many parameters do we calibrate? So what are indeed the parameters which we calibrate, which in a way they compensate for the uncertainty? We try, to introduce parameters precisely for this reason, because even if we have physical basis, we don't know hydraulic conductivity, and therefore we calibrate hydraulic conductivity in a way to minimize uncertainty. And of course, when you train a model, the larger the number of parameters and the larger the flexibility, which means that if you look only at training, it is relatively easy to train the model in a way that it gets very good in reproducing the data, because it is trained for this data. The real question is that when I make a prediction, the model is not trained. So what is the performance of the model then when I make the prediction? And therefore, we try to test the model. So we don't use all the data for training. Training is also called calibration. Training is a specific term for machine learning, but in the classical literature, training is called also calibration, optimization. And therefore, the idea is, let's suppose that I have 10 years, like Ilaria was, I think, 18 years, from 2016, from 2002 to 2018. Let's suppose we have 16 years of data. I trained the model only on the first 14 years, and I leave aside the 2 years of data. I don't use them in calibration. And once the model is calibrated, I try to predict these 2 years as if I didn't have the data. So it is a kind of a text of a real prediction. It is not a real prediction because the data, I have observed the data, I have them. But I pretend that I didn't have them. So it is like when I try to make a prediction in the future. And this is also called backcasting. Backcasting means prediction, but not for the future, for the past. And this is the idea of testing. This is why I asked the question, okay, these two models, and she replied only partially because she said, okay, here we don't see the statistics, but actually, even during the testing period, random forest was better. I can tell you because I revised the paper, it's a little bit better, not much better, because if you look at the graph that she showed, it seems like random forest is much better. Actually, in testing, it's a little bit better, not much better. But on the other hand, we also tried several experiments and with different cases, for instance, river flow forecasting. And it looks like, indeed, in river flow forecasting, where the uncertainty is lower, because groundwater is really a big issue, it's really complicated, for the very reason that you don't see it. For the rivers, it's easier because you see the river, so observations are more reliable. The geometry of the system is defined with more detail because you see the river. The surveyor can go there and give you the cross-river sections. So the uncertainty is lower. So for the cases where uncertainty is lower, we need to realize that the physically based model is better than machine learning in prediction. In calibration, machine learning is outstanding. Of course, it may have like 400 parameters. The random forest that Ilaria showed to you, I think it has like 250 parameters. So a lot. And so with so many parameters, even in the flow prediction, they were better. But we are still trying for random forest in testing. For river flow, it looks like the physically based model are better. Okay, good. Now we are trying the LSTM with the polymer, which is a typical case. We have a lot of data, etc. We are trying with the LSTM. But this is an open question in the literature. In the literature today, there is an explosion of machine learning. An explosion. And everybody uses it and replaced other physically based models. And for the very reason that if you have a powerful PC, it's much easier because Ilaria was quite low profile. She said, no, flow is not a big problem. Indeed, it is a big problem because, to put all of these parameters, and there are like parameters measurements. Hydraulic conductivity, you have to give it in any cell. And the cells are, you see the area, they are 1 kilometer by 1 kilometer size. 35 layers, so a lot of data that you have to put into the PC, and it's not so easy. She's used the Excel file and uploaded the Excel file on Flow. It's not easy. Random forest, machine learning in general, it's very easy. If you see the codes that I put on my website, they are very easy. And you can very easily make rainfall runoff model with random forest. I try it in a few seconds. It's very easy. So for this reason, people use it more than in the past because we have the computational power. So this is the reason why there is this high popularity. But on the other hand, it's still an open question, and often when we submit papers, the reviewer always asks what about reliability in out-of-sample application, which means testing, which means validation. Out-of-sample means out of the sample that you used for training. It's an open question. And indeed, also when we review research proposal, frequently this is something that is not really well clarified. But if you have 400 parameters, I was used when I was a student for rainfall modeling to use at least, at most, but really at most 10 parameters, better 5. And now we are dealing with models with 200 parameters. It's true that we have 20 more years of data, but it is not really justified. And from your point of view of technical application, maybe you have to be aware of this. So you have to get trained to recognize the model structure, what are the key elements like number of parameters, physical basis, yes, what kind of physical basis, what kind of equations, input data, what kind of data I have, are they reliable or not? So you have to take care of getting some experience in model application, model testing, and the only way to get it is to try. So you have plenty of data available on the web. You start from my website, and it's very easy to apply random forest, machine learning, try to make some testing, try to see what happens if you decrease the length of the calibration period and increase the length of the testing period. Try with many trials, you quickly get a perception of what are the possible strategies. And this is the suggestion that in closing this topic, I feel I should give to you. Now, actually, the topic is not really because, and now it's time to share the screen.
There to compare which one is better is maybe we have to wait until, let's say, if the prediction predict year like 2030, so we'll have to wait until 2030 and to see the true data, and then we have to compare which one was really good estimated. Maybe that one's good.
Yes and no, because in principle your reasoning is correct. But for instance, in the application of Ilaria, she assumed that rainfall is decreased 20%. And if this doesn't happen, it will not happen actually. If it doesn't happen, then the testing is still. So it is indeed a bit complicated to say how much the aquifer is resilient.
Maybe with the without decreasing, or we have the first scenario without any decreasing or increasing. Yeah. Maybe when you compare with that, maybe we see which one is better.
Yes, and one other thing that you could make, because let's suppose that you really have the resources for making several trials. So one thing is, okay, you are entertaining yourself with a modeling experience. Consider more than one model. This is why we wanted here, because the question is relevant. So we wanted to try machine learning, because now it's the dominant mainstream, okay? And this is the first thing. One other attempt, which we didn't make, could be, okay, let's suppose that we have 18 years of data, and we want to see whether the model is reliable in predicting, without training, a situation of scarce rainfall. What you could do is, okay, in these 18 years, let's remove all the years with few rainfall, low rainfall. Okay, let's suppose that in 2008, you got a rainfall that is 30% less with respect to the long-term average. Let's exclude it. So let's exclude all the years, not just the last two, all the years with rainfall below average. And you train the model only with rainfall above average. And then you test what happens when you try to simulate without training those years where rainfall is below average, and you have a comparison with the data. And this can be a strategy. And actually, when you get into modeling, you shouldn't blindly trust a model, the first one that you try. You should really do the opposite. Don't trust and challenge the model. Challenge the model with a comparison, with
different trend.
yeah, using it in difficult conditions and see what happens. And this is basically what means being a good modeler, being aware of the limitation of the possible critical issues and try to challenge the model and see what happens. Very frequently it happens recently also in the scientific literature, because, you know, scientific literature, it doesn't involve any responsibility. It's an attempt that you make to increase your knowledge and to disseminate the knowledge that you have increased, but you don't have responsibilities. And scientific publishing is also necessary for progressing in the career of academics, researchers. So in the scientific literature, it happens that sometimes papers are published which are not very tested. So even in this case, this is an advice that I give to you. The scientific literature is flourishing. Don't trust blindly the first paper that you read, because you have to be well aware that there can be something wrong.
And also, when we select for the data for training, so what is the contribution for the testing data? Also, because what is the contribution, and then why is the percentage of training data are more?
You mean what is the contribution of training? What do you mean?
So the contribution for, like, first we train the dimension.
Okay.
Then we use this data for prediction, yeah?
Yeah.
So what is the contributions of the training information? Why don't you only test the data without training?
Because if you only test, you could do this. But if you only test without training, it's very unlikely that you get a good response from the model. The model is flexible by definition, and therefore you need to find the shape of the input-output relationship that better adapts to the data. So the model is conceived to be flexible because it has to adapt to the data. So if you don't train the model, indeed, it's unlikely that you get a good result. And then there is a large literature on what to do in absence of data. But this is a step forward. Let's assume now that we have the data. And if you have the data, you have to train the model. This is the answer to the first question. The second question, if you remind me.
Why we use more data for training, like 70% for training? 70%?
Because the larger the data set for training, the better it is. But you could do one thing. There is a strategy. You need to extend the testing, which is called cross-validation. Cross-validation. So suppose that you have 11 years of data, okay, from year 0 to year 18, okay? So what I did is to stop at 16. Okay. And this is validation, and this is all testing, and this is calibration or training. So calibration or training, validation or testing. Okay. Many people already, starting from 20 years ago, they said, okay, let's repeat this validation calibration testing several times by randomly excluding 1 year or 2 years. So you could say, okay, this is one attempt. Now, let's take a second one. This is testing, and this is calibration. Okay? And then you could say, okay, let's take this then. And this is cross validation. Cross because you validate across all the data. Okay? And then it's also called jackknife calibration because it means knife because you are cutting data and you are cutting data systematically. So in this way, you see that you can extend the validation, and then at the end of the story, you get several performances. You can take the average. And on the other hand, it is computationally demanding. It is a bit complicated because calibration is training. It's automatic, but if you want to be very careful, you should look at it, look at the results, not just blindly take, okay, this is calibration, let me test it. Because it may be that something goes wrong. Sometimes the algorithm, because it's always an optimization algorithm, which may not converge. So anytime that you calibrate, that you train, you should look at the convergence, at the statistics of the convergence. So it's demanding, but this is another possibility. So, yeah.
The second one is backcasting.
It's always backcasting because you always look at the past here. And even if you start from 16 and you simulate 16, 18, back refers to back with respect to the current time. So 16, 18 is before than today. Okay, it doesn't refer to back before the training or after the training.
Already observed.
Yeah. Okay, now we started talking about LSTM, and we said LSTM is a good idea because they are better in reproducing the memory of the data. The memory of the data is particularly important, we said, if we want to study droughts. With respect to this, this is a different network, is a different neural network, is a different machine learning. With respect to random forest, these are better in reproducing the memory of the data. What is the memory? The memory is the fact that if you look at the river flow today, it depends from the river flow yesterday. And in some of the cases, as we discussed last time, we observed that the memory, the river flow of today depends on the river flow of 10 years ago. This is the long memory, which means that some processes have a long persistence. Very good. Now, how these networks work? It is a bit complicated. Now I will show you a sketch. It's a bit complicated. So understanding it is not easy. And you may wonder something like, why did they conceive a similar complicated structure? The reason is that they really wanted something that was able to reproduce a very complicated process because memory, I mean, if you think of something that depends on what happened 10 years ago, it is really complicated. You have to keep the information for a simulation that is 10 years long, okay? And in climate science, climatic processes, indeed, there is the feeling that there are cycles like glaciations that last for 10,000 years. And therefore, to keep, if we assume that they last so long because they keep the memory, so what happens during a glaciation may have been an eruption that obscured the sun for 1,000 years. So it's a shock that is remembered by the system through the dust in the atmosphere for 10,000 years. And therefore, you have to create a mathematical relationship that keeps this information for so long. So clearly, people started with something relatively simple like random forest. By the way, random forest is not very simple, but still, I mean, it's something that with a sketch can be easily understood. But then they saw that random forest couldn't keep the memory for long time steps, for several time steps, and therefore they tried to complicate things. Okay, let's introduce a node that keeps the information. So in this node, the information is stored for a long time, and they devised some mathematical relationship that was able to do that. So in this way, if you take into account this need, then you may understand how LSTM works. And basically, the LSTM is at the core is a cell. So you could write over the blackboard a rectangle where you get an input, like in this box there, and you have to put an output forward. But then what happens to the input once it gets inside the box? It's a sequence of transformations. Let's try to understand them in detail. So basically, there is the first thing that happens to the information when it gets into the sketch. The sketch is this one, but it's not easy, okay? And don't try to understand from the sketch. Let me open it larger. So the first thing that happens when you get into the cell is this one, okay? And then in the cell, you have the input, xt, that comes into play, but you have also a cell state, C, which is preserved from time to time. So here, somewhere there is a cell state C, where is it? Here, CT. Okay, it's a component of the cell, it's a variable, it's a state variable, and this state variable depends on the same state at the previous time step, okay? And then there is an hidden state, something that is called hidden, in principle not shown, but it is used to compute the state. It is like an intermediate step. And you may ask yourself or myself, what is the logic of a transparent state and the hidden state? Couldn't they compress it into only one? Yes, but in this way, you reduce the complexity and you don't keep the memory anymore. This is my explanation. So basically, keep in mind, machine learning doesn't have limits, doesn't want limits to the number of complications, which means number of parameters. It's not a problem. Machine learning is willing to accept that you train 1,000 parameters. No problem for machine learning. So basically, they realized that they needed something hidden. They called it hidden because it's not something that is directly used, but it is used to update the state, and the state is used to produce the output. And then in the unit, then you have these two, which come into play. The hidden state, H, at time t minus 1, and the cell state, C, at time t minus 1. This was produced in turn with the input at the time xt minus 1, and this cell at the time t minus 1 producing an output at the time t minus 1. Very good. And then, of course, at the time t minus 1, they got, you see the three dots, the state and hidden state at times t minus 2. What happens once that you get into the unit with the input and the previous states, hidden and transparent state? What happens, first of all, is that you have a first transformation, which is called a gate, that is called the forget gate. The forget gate, depending on the state, ct minus 1, and the input xt, through a rescaling, the sigma is a rescaling, is a sigmoid function, produces a variable ft, which is called the forget gate. It's an index between 0 and 1, between 0 and 1 because it is rescaled by the sigmoid. And this index quantifies what has to be forgotten with respect to the previous state, Okay, so ct minus 1, if here you get ft 0, it's discarded. If you get ft equal to 1, the previous state is conserved. And then you move forward. You move forward, and then there is another gate, the input gate. The input gate is receiving the input, and depending on, here is not clearly displayed, depending on the state of the cell, okay, again, like the forget gate, depending on the state of the cell, it is through, again, a sigmoid function, it is given a value between 0 and 1. 0 means I don't consider the input. 1 means I consider the whole information that comes from the input. And then from the input gate, you go into this further transformation. This further transformation gets the output from the forget gate, the output from the input gate, and produces a result which allows to update the state of the cell. And then through another transformation produces with some more steps the output. And then you move to the next time step with a new state and a new hidden state. And you see that here there is also mentioned the hidden state, which contributes to determining some of these results, intermediate results. I don't give any more detail, and it's not important that you get all the details. I mean, it's not important. What is, in a way, useful for you, if you want to better understand, here there are a couple of very simple examples. So this is a trivial numerical example. So let's suppose that you have a state t with the number 1, and the previous hidden state is 2.5, and the previous set state is c t minus 1, 0.2. And then here there is a numerical example of the transformation, of how these transformations are computed. They are very simple. Basically, we introduce weights, and these are the parameters of the LSTM. These are the parameters that allow to make it flexible. We introduce weight, and so basically you see the forget gate is computed in this way. There is a sigmoid function which takes the weight of the forget gate, WF, 0.7, 0.3, just to give you an example, but these have to be calibrated. So these weights are multiplied for the hidden state at the previous step and the input at the current step. And then there is a bias, another parameter to be calibrated. And therefore you get a sigmoid function simply of this computation, weight times ht minus 1, weight times xt, and here the bias is 0, is assumed to be 0. BF is assumed to be 0. BF is 0, yeah, BF is 0. There is a plus, yes, of course. It's a multiplication, vectorial multiplication. And then you get a result that is 0.35 plus 0.3. If you get the sigmoid function is a simple rescaling function. And there is a link here if you look at sigmoid. This is the sigmoid function. And it is a rescaling function. For instance, you can use the logistic curve to transform data in the interval 0, 1. And the sigmoid function rescales any data range into the interval 0, 1. Okay, and an example is the logistic function. Let's go back. So in this way, through this numerical example, you have a very simple, okay, explanation of how the computation is done. And then here it's the final result for the output, for the cell state, and for the hidden state. Okay. So this is what you may look at just to get, not to learn, I mean, not to learn it by memory, but to get an understanding of what it does. And because it is very simple, but there are many of these transformations in sequence. And it's nice to get an understanding because in this way you can really apply the software in 30 seconds, but you gain some sensitivity to be able to evaluate the results. Now, this is an example for several time steps. So first I gave an example for one time step. And now you see here, let's walk through a multi-step sequence to better clarify evolution over time. And then it's a multi-step sequence. When I prepared this lecture, I didn't know anything about LSTM. I just wanted to write something that was understandable, at least to me, but I tried to adopt a perspective really of a learner, and I am a learner, because then I want to apply it at the PORIVER. But it's very easy to run the code over the PORIVER. It's very, very easy. But I want to get the perception of what's going on, because I want to really understand why the model is correct or why the model is wrong. And the perception, you get the perception only if you get an idea of how it works. And now this is, for instance, this is, for instance, an example of application, and this works. It was tested, so you can take it, put it over R. You just have to make sure that you have installed the packages that you need. Okay, but this is, I think, it's a code that I wrote myself. So myself, taken by the web, and check that it works. It doesn't use any software, because this is simply the code that makes a three-step computation like the one that I did earlier, and it doesn't involve calibration. But then after that, there is two example codes, and they use indeed, in this case, a package. And then there is an example of application with calibration, etc. And this package is very easy to use, and it is very fast. It works really well. And I plan to use this code with the data of the PORIVER, which, by the way, I think you don't have the rainfall, because unfortunately, with a big river, the problem is to get the rainfall, because the spatial average is not enough. One has to consider rainfall in several points of the catchment. But in any case, you can find over the web, if you're interested, some input-output data readily available, and you may use it. And you see here an interesting question. How many parameters, weight and biases, does the above LSTM count? And here you see 481, and it's a very simple one. Okay, and that's it. And then here there is a very quick conclusion. Again, this is material from the literature. If you go back to the literature 10 years, I think you find in climate science and engineering, you find no applications of LSTM. If you look at the literature of the last year, you find like 100 of them. Okay, and it's something that is evolving, and there are some questions which are still not answered. Like, what is it sensible, reasonable in engineering using so many weights? And sometimes, if you look at the scientific papers, they don't even mention the number of parameters. And if you ask the authors, maybe they don't know, because the software doesn't tell you. And you just have to look. In order to make this count, I asked ChatGPT, and then several challenges. I challenged ChatGPT many times, or Grok, or whatever artificial intelligence. It's not an easy question. Okay. Okay, good. Now, I think that for the part of the lectures which we may call theory, we are done. I think I never proposed to you the survey for the opinion of the students. I will send you an email, and I will an email through the forum and over the Teams chat. I will give you the code, and I will left it open to give you the time to complete it. Please complete it. You are few, so I will monitor if you complete it. And you are not a number large enough to make them statistically significant, but still I am interested in your opinions. And of course, anonymity when there are only 6 students, it's a bit of it's not real anonymity, but trust me that it will be only useful for you if you complete it. We don't regret any. We welcome any critical comments, in particular the critical ones. And I will send you an email because today I don't want to take your time with other formalities. Instead, the exam, let me just check because we agreed with Serena the dates, but I didn't have time to put them on Albesani. I will do it soon. Takes a little bit of time to me because it's the first exam that we make. So let me see. I think the first one is June 12th, but let me check. So the first Monday when we can make the exam, that's it. Second. Calendar. Okay, good. No, it's not 12 because 12 is it's a Friday. Okay, let me check. So I think it's then 8, June 8. This is the first date, and it will be at 10 a.m.
There is overlap. Overlap. Yeah.
With what?
In one subject. First subject.
Okay, so what time is it, the exam? Just to understand if it is just enough to move to the afternoon or not.
At 9.
Hmm?
9.
9 in the afternoon. Do you think you will be free, or would you prefer to go the next day early morning?
In the 9th.
Yes, or the 10th.
June.
They are busy the 8th of June. Probably you are not because they have another exam. So my question was, would you prefer June 8 afternoon or June 9 morning, June 10 morning?
June I have exam.
June. Sorry.
It's the
Which at 9.
9.
Yeah.
9 of June.
Yeah.
So shall we move to June 10?
10 will be better. Yeah, are you free on 10?
10 years.
Yeah, push 11.
12 is possible.
12, no. I would prefer because I'm quite sure that Serena may be not available. Let's stick on 10. Okay?
11 also no.
I don't think she's available on that day.
Yeah, 10 is okay. Also 10.
Okay.
In the morning.
Yeah, 1 second.
But we will have offsite time.
No, sorry, June 10 I cannot. I have maybe June 10, but in the afternoon. It's okay in the afternoon? 2 p.m. 2:30. Okay, I will send you the dates, then a summary of the dates, and you will see the dates of Albesani. So June 10 at 2:30. Okay, good. The next one that we thought of is June. June 22nd is okay for you as a possible date.
Is it possible to get end of the June?
There is another date in July, so if June 29, the last week of June, I cannot. So I would prefer, otherwise I can make it the first week of July, so after 2 weeks.
No, we mean on that week of 22nd, just extend to maybe Venerdì 26th.
No, I cannot, I am abroad from the 24th to July 5. So I need to, maybe for me, maybe good the 22nd or 23rd. But
If you want process, we can decide that after June 10th.
I prefer, because I prefer to make sure, especially for Erasmus students, what are the dates in which they can take the exam. They need to know now because I don't know, they may have the plane to fly back.
Process in schools?
I think you. Okay, okay. But I'm not sure, maybe that somebody, some Erasmus students put it in the study plan. So I cannot postpone, I need to decide now, it's already too late, and I need to fix dates in Almesani. Then I may change them, but the problem is that it's a problem for me to take another week. So let's keep June 22nd. Okay, and then there is, because you have other exams, no, it's just, okay. And then July, it's, I think it's 13 at 10 a.m., July 13. And this will be the last one before summer. And then 13 of July, the third one. And then there will be another one, of course, in September. But I hope that with these 3 days, you can pass the exam. Our feeling is that, but you choose, it's no problem. Given that you are few students, we would prefer to make it only oral, no quiz. Is it fine for you? And because, the quiz, I think that this is for your personal benefit, because the quiz may induce you to get less prepared on the oral, and the oral is important. And also because the quiz now we would need to make it restrictive in terms of access to the web. You cannot access to the web, so, and then you cannot access to my website. So you would need to, to make. So basically, printouts, which is so. My suggestion, it's better to go with the oral, and I give you another information. Our intention, you are the first students for this exam, is to be not restrictive. So my prediction is it's very unlikely that you don't pass, but please keep in mind that if you aim to get the max, if you aim to 30, you need to be very well prepared. And so don't be discouraged, because it's very unlikely that you don't pass, because basically you attended the lectures. So we want also to take an attitude that is not restrictive. But on the other hand, try to don't assume that it's easy to get 30. It is an exam that needs some preparation. And then we will not be very strict in asking any single equation. As I told you, it's not the problem, but you need to have quite a good perception of what we did. This is what I recommend. So don't assume that it's easy to get the max mark if you aim to it. But on the other hand, I tell you, it's very unlikely that you get a very low mark. I'm not, I think it would be a GAV distribution with a very low frequency. Okay. And that's it. But I am sensitive to your requirements in terms of quiz, no quiz. For us, it's not a problem to prepare a quiz. And just for your, I think for your benefit, and I think it's much better if we can clarify face to face what are the doubts, and I think it's more convenient. I mean, the quiz is fine when there are 60 students. It becomes the only possible solution. But when there are few students only, for us, it's not a problem. But in any case, if you have some reservation, you can also send an email. The important thing is that you don't say it the same day. We need some preparation, because otherwise we don't prepare the quiz if you are willing to go with the oral only, and that's it.
But is the problem if it's boys?
Sorry?
If it is boys,
Both oral and quiz.
It would be better not to be able to choose, because it becomes complicated, you know. And because if you come for the quiz, I think we will set a separate time.
if it is close, it's okay. Like close the exam, like not like searching or looking the web.
Mm.
But it's normal to if it's close.
Mm.
Like
I mean, you can, if you select the quiz, this is fine, but then it will be quiz plus a short oral, and you can choose it. I just need to know it in advance. It cannot be a quiz plus a long oral. This is not possible. Okay, and then which means that if you choose the quiz, you will have only a very short opportunity in the oral to demonstrate that. And the oral is what counts more, you know, because I think you have the experience of the other cycle. I mean, if the oral is not good, there is no way of not taking it into account. Okay, and the oral, in my opinion, in our system, when there is quiz plus oral, is what really makes a difference.
What's the way?
There is no weight, but the oral indeed makes a difference, because you understand why. Because in the oral you cannot look at the lectures. You cannot. It is what really proves how much you are confident with something. The quiz is the weight of the quiz, or the importance, decreased a lot after the advent of artificial intelligence. It's clear that we cannot give a lot of weight to the quiz, so our plan is in the future to completely discard it, because it is not anymore an indicator of your preparation. So this is why I think that we are giving more and more consideration to the oral, and this is why my suggestion for you is take into account that if a longer oral is more attractive, in my opinion, because you cannot, with a short oral, ask for, please ask me one more question, one more question, one more question. There is no way. The short oral is one question, and if you fail this, so this is why I feel that it's better if we have an interaction, personal interaction, that is longer, because you have more opportunities to discuss with us. And you understand that we cannot give both opportunities, because it looks like one chooses the solution that day by chance is more beneficial, and we need to be unbiased with respect to all of the students. So the choice is, you can take the quiz, but then you have only one question in the oral for an important piece of your assessment. This is why I am suggesting, you know, if I was you, I would prefer to have an interaction. Because if you are prepared, it's much better to speak. And of course, if you are not prepared, then the quiz gives you one more chances, because you can try just, you know, the reply by chance, and by chance you may get it. But for this reason, we need to give lower and lower weight to the quiz. Okay? And, but if you want to quit, just, we need to know at least 1 week before, okay? And then we can do that. Perfect. Any more questions? Okay, let me just close the registration. Okay, that's fine. Thank you very much for your patience, because